And I'm going to start with talking about the course schedule. Um, and we've been through a lot already in the spring with the pandemic and now this Arctic storm that we've had to survive. Hopefully, we are all surviving it and, getting, past it or getting the resources we need to cope with it. So that leaves us here at 224. Our scheduled topic of discussion was supposed to be Introduction to One-Way ANOVA. However, because class was canceled on last week, we were not able to conclude the remaining portions of the discussion of T-tests. So tonight I'm going to spend our time going over the remaining components of T-tests, which we were not able to explore last week. And then next week, on March 3rd. As you can see, on March 3rd and March 10th, I have those two class periods as allocated for ANOVA. And so we had enough, space in the course calendar to, take a little bit, take a little time to spend on ANOVA. So luckily, we'll still be able to, keep those 2 days on the schedule so that we can review it comprehensively before we are out for spring break. And then as far as the assignment, so tonight I'm going to talk about homework number 3. We have, kind of gotten behind on the homeworks as well. So homework number 3 is available. Last week in my mind when we were to meet, we would discuss homework number 3 in class more in depth about the creation of a study, the creation of a study proposal using T-test. However, now since we lost last week, that has been transformed into a homework. And so I will touch on that tonight, and you'll be able to complete that, and it won't be due until March 7th. And so I just wanted to kind of talk about the course schedule. As far as the midterm before spring break, I'm not sure if the university is going to change the midterm schedule. At this time, I'm currently waiting to see if they are too going to push it back a week. If not, we will maintain the midterm schedule. Typically, how I administer the midterm, I'll release the content that week, which would be March 1st, technically. So I would release the content, and then you would have at least, I believe, at least 10 days, 10 to 14 days to submit it, depending on when midterm grades need to be submitted.
Where's your phone?
I have it right here. Okay. All right, so.
I have a question.
Yes.
Since we don't have midterm, since we don't have spring break, we're not gonna have class on the 9th week, right?
Right.
Okay.
Any other questions? Okay, so good question. And like I said, if the university pushes the reason why the midterm is scheduled like that is because typically they require the grades to be inputted by a certain deadline. Usually it's around the 10th or the 12th of March. So I'm not sure if they're going to be rescheduling. I'll stay on the lookout for that correspondence. But like I stated, if that doesn't change, typically my midterm is administered online. It is open book, open notes. And so you'll have a chance to complete that. I'll make sure that you have ample time to complete it, and that I also have ample time to input the grades into the system that they require. Okay. Now I'm going to go ahead and go back. And so we've been through a lot. It might take some time to kind of get reacclimated to what we've been talking about in stats. As a reminder to kind of jog your memory, the last time we met, we were talking about our first statistical model, T-tests. And when we started talking about T-tests, we got into the operational definition of T-tests, the purpose thereof, and what exactly is going on behind the scenes. In other words, what is that software doing to calculate that ratio so that we can, in essence, receive a T-score so that we can determine whether or not out there are statistically significant differences between the groups under investigation. And so with that, I'm going to go ahead and start back at those first slides. I'm not going through all of the first slides. You have access to all of these PowerPoint slides. I just want to hit on one from the slide from the previous week again, so that we can begin to construct our knowledge around t-tests, so that your memory is jogged a little bit. And then from that point, I'm going to review the slides that refer to the t-test assumptions. And then thereafter, I'm going to spend some time talking about t-test interpretation, the output interpretation. And when it comes to homework number 3, the homework is closely aligned with tonight's lecture material. So I'm also going to spend just a little bit of time at the end of that to review homework number 3, so that you're aware of what the requirements are and what I'm looking for as far as the submission goes. So I'm going to share my screen right now with, as stated, that first introductory slide, those first introductory slides that talked about what is a t-test. If this information is fleeting right now, if it's not even, a memory at this point, I really do suggest, whenever you have some mental capacity at the space to, take on that information, to go back and revisit those slides from the previous weeks, refer to the text, make sure that you're unpackaging definitions and terms that you may not be aware of, so that you get a real good understanding of what a t-test is. It is a model, a statistical model that is available to you in some journals. For example, one of the ones I've posted in Blackboard, that particular study used t-tests. They used, I believe it was 8 paired t-tests in their particular study. And so it is a way in which you can analyze the data for your dissertation or for any of the works that you may be doing thereafter, or as an antecedent to the dissertation. So just as a reminder, what is a t-test? The t-test, also called student's t-test, compares 2 averages, means, and tells you if they are different from each other. So at its core, right, the student's t-test, or the t-test, or you also may hear it referred to as the independent samples t-test. Sometimes you'll hear it referred to as the paired samples t-test. And these different names really refer to the type of design that the t-test is undergoing. However, at its core, we know that whether it's a paired sample t-test, independent samples t-test, if it's considered a student's t-test, we know that the main purpose of it is to compare 2 averages and tell you if they are different from each other. So more than just looking at averages or looking at the raw data and kind of eyeballing and determining whether there is a difference, the t-test allows us to statistically determine if there is a real difference, or if that difference is just happening by chance. And that's really what that second bullet tells us. How significant the differences are, and when we're referring to how significant the differences are, remember, that's a reference to those alpha criterion levels, that 0.05, 0.01, and 0.001. So it's going to tell us how significant our differences are by those criterion, and then it's going to let us know also if those differences could have just happened by chance. So in other words, maybe there's not a statistically significant result, and so these differences are just happening by chance. They're not, correlated with any other factor other than they are naturally occurring in the environment. But the t-test, again, allows for us to compare 2 averages, or oftentimes I'll call them the means, right? And it tells you if they are different from each other. Just a quick question, just to check in with you guys. Just out loud, tell me what an average is, or how do you calculate the average?
The sum of everything divided by the n.
Very good. And so when we think about average, and when we think about what the t-test is taking into consideration, I want you to always remember that it's comparing two averages. And so when you're thinking about a t-test, you're going to have one group that has an average, group A, and another group that has an average, group B. They're being compared on the same uh, measurement as far as the dependent variable goes. So, for example, in a t-test, and we'll get into this a little bit more once we get more into the slides, but remember, the t-test is going to tell us whether or not there are statistically significant differences between the independent variable and its various factors on that dependent continuous variable. So in other words, we're going to have a group A. Let's say we're interested in looking at one class with boys and girls, right? Boys and girls, that would be considered gender. So gender would be our independent variable. Our independent variable would have two levels. So our two groups would be boys and girls. So boys would be group one, girls would be group two. And let's say we're interested in understanding the differences in their star scores. You know, I'm just using this as an example, that their average star scores. So theoretically, if we had a class of 15 males and 15 females, we would get the scores for all 15 males. We would add their scores together. We would get the average, and we would do that same practice for the females. And then we would then compare those averages and determine whether there are statistically significant differences between the two. Now, again, the t-test takes it a step further because not only does it consider the differences between the groups, what else does it consider? I'm sorry, I'm flipping through the slides. I'm looking for the slide that explicitly tells me the answer to this. But again, if
Is it the probability of it happening by chance?
No, it's not quite that. So when we get the t-score, it tells us, it provides us a ratio, and it considers not only the differences between the scores between groups, but it also takes into consideration what? And it's outlined in this first bullet on the t-score.
Do you mean it tells us the difference within the group and like
Yes.
both vertical and horizontal, groups?
So it tells us, so when we think about the t-score or running a t-test, it's important to conceptualize that the t-score is not just looking at the difference between the groups, but that it is also taking into consideration the difference within the groups. So that is how SPSS comes up with the t-score, this composite score, which is then correlated with a significance ratio or an alpha criterion, so that we can determine whether or not the difference is actually significant or not. So again, just in brief, as a reminder, the t-test, and I'm going back and forth, and I'm sorry, you guys, but I just wanted to make sure I use these as visuals. The t-test, by definition, compares two averages and tells you if they are different from each other, right? The t-test also tells you how significant the differences are. In other words, it lets you know if those differences could have happened by chance. And so again, on its face, the t-test is going to compare two averages and tell you if they're different from each other. How does it do that? Well, it takes into consideration the difference between the two groups and also the difference within the groups. And then that ratio that is produced is called the t-score. As a side note, when I state in the homework, report the t-statistic, it's synonymous with the t-score. Okay. All right, questions about the purpose or the definition or the function, in other words, what the T-scores, actually considering. Any questions about those components of the T-test? Okay, and feel free to drop your questions in the chat. I'm more than happy to revisit them at the end of the lecture. And so now I'm going to go ahead and turn to the next part of T-test, the discussion around T-test, which is the assumptions. If I could just get a thumbs up, does everybody see the T-test assumptions slide?
Yes.
Okay, great. Thank you so much. So with every statistical model, there are a set of assumptions, okay? In real life or in regular life, we think of assumptions as these notions or ideas that we make about certain people, things, institutions, that's sometimes grounded in fact, but other times it's just it seems like common knowledge to make these determinations about certain occurrences. That same definition of assumption carries over into statistics. And what a statistical assumption is a notion or an idea that has to be, that your model has to meet. So this certain criterion that your model has to meet in order for it to produce the most effective results. And it is assumed that when you run all the statistical models, whichever model you so choose, that your data fit within this particular framework. And that's how we arrive at statistical assumptions. And so just as an FYI, T-test, as we go through the semester, the T-test assumptions will kind of serve as ground zero or the foundation of assumptions, because as stated in the beginning of the semester, each model becomes a little bit more complex. And so understanding foundationally what's happening with some of the more simpler models will help you create an understanding of the more complex models. And so that's why we start with T-test, and that's why it is important for you to understand the T-test assumptions, because from this point on, each model builds on these set of assumptions and adds a few more as the models become a little bit more complex. And so, I'm sorry, my TV just did not turn off. So assumptions. The common assumptions made when doing a T-test include, and these are the assumptions for a T-test: scale of measurement, random sampling, normality of data distribution, adequacy of sample size, and equality of variance and standard deviations. And so I know that may seem very statistically jargon, esque, but we're going to go through each of the assumptions and I'll unpack them so that you're able to understand. But as you're looking at these definitions or these terms, I want you to begin again to unpack them so that you have a real comprehension of what they mean, because as stated before, as we move to the more complex models, they build on these particular assumptions as we move forward. So assumption number one, the first assumption in T-test concerns the scale of measurement. The assumption for T-test is that the scale of measurement applied to the data collected follows a continuous or ordinal scale, such as the scores for an IQ test. So That is assumption number one. Again, it refers to the scale of measurement. And when you're thinking about scale of measurement, or when you see those terms, the four scales in which we've talked about, or that you have, gained more experience with over the span of the semester between 931 and this course, are the nominal, ordinal, interval, and ratio. These are the scales of measurement. In other words, scales of measurement are different ways in which we measure the data in which we are analyzing. And for the t-test, the assumption is that the scale of measurement applied to the data collected follows a continuous or ordinal scale, such as the scores for an IQ test. So in other words, whatever is being measured, and whatever's being measured is also equates to the dependent variable, right? It needs to be on a continuous or ordinal scale. So in other words, that dependent variable needs to be on a continuous scale, which could be, numbers 1 through 100. Another example of that would be GPA, writing scores. Anything that has a numerical value pretty much will follow on a continuous scale. It also accepts ordinal scale. And as we can recall, ordinal scale prioritizes rank, first, second, third. And so the t-test also accepts ordinal scale of measurement data. So just keep that in mind. The thing that you draw the component of the t-test you can draw this assumption to, as far as understanding t-test, is that, remember, t-test is comparing averages. And so when we think about comparing averages, how do you compose or get to an average? Well, you have to add numbers together, right? And divide by the number in that particular sample, or in that particular cohort, or in that particular group to get an average, right? And so again, in order to average something, we have to have numbers. And so numbers equate to continuous or ordinal level scale measurement items. So again, that's just one kind of way to make those connections between what the t-test requires and the assumptions that it also holds. Assumption number two is that the second assumption made is that of a simple random sample, that the data is collected from a representative, randomly selected portion of the total population. And so this again really speaks to the validity of our results. We want to ensure that the samples taken are representative of the population in which we seek to investigate. And then we also want to make sure that depending on the independent variable, that each person within the sample has a equal chance of being entered into group A or group B. As we'll see with some of the independent variables, such as gender, those categories are in some ways kind of predetermined. So girls don't have persons who identify with the female gender, they may not have an equal chance to be in the male gender group. And so that's why this assumption is, it is applied to t-tests, but in typical educational research, sometimes there are some caveats to this, but for the most part, as a practitioner or as a researcher, you want to ensure that your sample is representative of your population, because again, the general goal is to tie back whatever findings you have to that population. So we want to ensure that our sample is representative of the population that we wish to investigate. The third assumption is that the data, when plotted, results in a normal distribution, bell-shaped distribution curve. When a normal distribution is assumed, one can specify a level of probability, alpha level, level of significance as a criterion for acceptance. In most cases, a 5% value can be assumed. So all those words to say that in a t-test, again, the assumption is that when that data is plotted, or when we have a chance to look at it in a graphical setting, that we'll see that the scores follow a normal distribution. Now, if you're unfamiliar with what a normal distribution looks like, or bell-shaped distribution curve, what that may look like, I really encourage you to look at that. You can look at it now while you're on the computer so that you can have a visual. I would pull it up, but Microsoft Teams is a little bit cumbersome when it comes to flipping back and forth between websites and sharing the screen. So definitely take a look at what that bell-shaped distribution looks like. But in other words, we're going to have scores that fall in the left side of the bell-shaped distribution curve, in the middle, and in the right side of the tail. And what this is saying is that your data, when using a t-test, it's assumed that you'll have normal distribution. Now, why is this important? We kind of visited this the last time we had a face-to-face discussion, because again, drawing back to the basic premise of t-tests, we're comparing averages of two groups. So in order to really do a fair comparison, we want to ensure that our scores are plotted normally on that distribution curve. And if we don't have scores that do that, then we need to further investigate what may be going on, because we know that if scores fall, in one far end of the tail on the left side, or if scores fall in the right side, all on the right side of the tail, then we may have some skewed data as it comes to interpreting the results. So again, the t-test assumes that your data is going to be normally distributed. And if it is not, and the way you figure this out is by directly looking at a plot of your scores. If it is not normally distributed, then you may have to, reconsider your data. You may have to clean up your data set. You may have to remove outliers or other scores that may pose a problem as far as making your averages skew to one side or the other. But again, for t-tests, the assumption is that there is a normal distribution. And again, the way you determine this is by looking at a plot of the scores and really seeing how the scores fall for those particular groups. And by ensuring that there is normal distribution, basically you want to make sure you see that nice bell curve, scores in the right side of the tail, scores in the middle, and scores in the left side of the tail. Assumption number 4, the fourth assumption is a reasonably large sample size is used. A larger sample size means the distribution of the results should approach a normal bell-shaped curve. So this is an assumption that you're going to find as you start doing your own research, particularly your own studies, possibly, that sample size is going to be fairly subjective. And depending on who you're working with, the researcher that you're working with, your methodologist, their sample size, or what's considered to be a sample size, a large sample size, again, may be very subjective. It may be contingent upon the field of study, the population under study, and again, just the area in which you are studying. But as a framework, what the t-test states is that, hey, if we have a large sample size, and from what I understand, large in some senses could mean 100 or more, again, depending on your field of study and your sample. To have a larger sample size means that we have more scores, that we could move more towards the assumption of a normal distribution, because then we have more scores on that bell curve to take into account. If you have fewer scores or a smaller sample, your statistical power may not be as strong. And I know I mentioned statistical power now, and we will talk about statistical power more in depth next week as we get into ANOVA. But when I say statistical power, I'm referencing the model's ability to produce results that can be replicated and accurate. And so we want to ensure that those things can be done with the model. And so again, an assumption for t-test is that you have a larger sample size, and that's going to be contingent upon the area in which you are wanting to study. Again, usually, typically what I've heard is 100 participants is a great framework to work around. But then I've also heard, advisors and researchers say they'd like, sample populations of 300, sometimes 500. When I completed my dissertation, I believe, my analysis included 1,300, participants. And so it really just depends on your field of study and the what's under investigation. But again, a safeguard for t-test is the larger the sample size, the better. Assumption number 5, the final assumption is, sorry. All right, so the final assumption is homogeneity of variance. So homogeneous or equal variance exists when the standard deviations of the samples are approximately equal. So homogeneity of variance basically means, well, the way that I like to break it down is when looking at statistical terms, they work just like definitions and terms in the real world. And I know I keep referring to real world because statistics is kind of in a world in and of its own. But even when we see the term homogeneity, we know that the prefix homo means same. And so what homogeneity of variance means statistically in this sense, that there's going to be the same amount of variance between the scores, so that, again, when we are looking at our averages and then doing the comparison, that we have looked at them in a way in which they're going to be fairly compared. So in other words, we want to make sure that the differences between the scores are the same for the scores between each of the groups. In other words, we want to make sure that there's normal distribution within the groups, and then we also want to make sure that there is homogeneity of variance, so that they're also exhibiting the same amount or similar amounts of variance within the groups as well. And that is important because, again, it draws back to normal distribution, and then that draws back to having the accurate information or scores that will lead to results that can be replicated. So we want to ensure that there is homogeneity of variance. And in our next slides, we'll talk about how you check for that assumption. So as far as the other assumptions go, there is a remedy for each of the assumptions. And I mentioned them kind of in passing, but I want to make sure that you're aware of them explicitly. So the scale of measurement, this is a design feature. This is something that you check on the onset before you actually run the t-test. So again, you check that assumption before you even enter any of the data into the software. You want to ensure that the data collected is using the appropriate scales of measurement. And for this particular test, the scale of measurement is referring to the dependent variable in which it has to be measured on a continuous or ordinal level of measurement scale. Random sampling, that also speaks to the research design. This happens at the onset of the collection of the data. So you just want to ensure that if you are, for example, collecting data from two different groups in the class. Maybe one's getting intervention A and one's getting intervention B. As the person who's designing the intervention and determining who gets into either group A or group B, that's when random sampling really comes into play. You want to ensure that your sample participants, all of them have an equal chance of either being assigned to group A or group B. And, you know, we do this in educational practice a lot without even knowing it. Sometimes in the classroom, we number students off and, you know, then they're randomly selected to go into group 1, group 2, or group 3, depending on the number that they stated out loud. And so when we think about random sampling, you can, again, tie it to those kinds of experiences. And again, it really just speaks to making sure that those participants all have an equal chance of either going to either group. And as mentioned before, there are some caveats to that, especially if you're using gender as an independent variable, in which in some senses, not all participants have an equal chance of being selected to each group. They're actually selected to go into a group. And so again, there are going to be some caveats with that. But for the most part, you do want to practice random sampling to ensure the quality of your data. Normality of data distribution, how do you check for that? Well, again, it's going to come from a scatter plot or a plot matrix. And for the purposes of this class, my hope is to get you acclimated or introduced to SPSS software. If you do not have it at this time, if you never heard of it, if you haven't seen it, I encourage you to look into it and to download it and to have it as a working app on whatever device that you're going to be using to write your dissertation. It is just software that is good to, again, become intimate with. And again, my hope is that within this class, you're able to at least get introduced to it. But there are functions within that software that will allow you to enter your data once you determine that you've met the previous two assumptions, and then allows you to put your scores into a plot matrix or a scatter plot. So then you can determine if you have normal distribution. And remember, we want to ensure that basically when we're looking for normal distribution, we're looking for scores to fall all along the bell curve. And we're going to identify scores that may be outside of that bell curve or that we may think are outliers that may skew our results. So that's how you check for the normality of data distribution. Adequacy of sample size, again, this is going to be contingent on your field of study. However, the larger the sample size for t-tests, the better. Just think of it as, the more scores you have, the better comparison you can get, and then you can really generalize your results to the population that is under investigation. So, but again, that adequacy of sample size is going to come from, at this particular phase, it's going to come from the literature review, understanding what other researchers are doing in your particular field, if they're conducting t-tests, what kind of sample sizes did they use. Again, your dissertation in writing that method section is not going to be the reinvention of the wheel, but more so have you done the research to really understand what's going on in your particular phenomenon of investigation, and do you have the framework needed to conduct a study based on the extant literature. So basically based on what other researchers have already compiled and conducted. And then lastly, equality of variance and standard deviation, or that homogeneity of variance. There is something called the Levine's test of homogeneity, and I'm going to visit it as we get into the last portion of t-test, which is going to discuss the interpretation of the output. So again, the basic premise of t-test is that it's going to compare the averages of two groups. It's going to do that by calculating a ratio that takes into account the difference between groups, in addition, the difference within groups. And that's going to produce for us a t statistic. Once we are ready and have collected our data, we want to ensure that all the assumptions associated with t-tests have been met. And the ways in which we do that, I just explained. And then the last one, the homogeneity of variance, I'll explain how you check for that in the upcoming slides. I want to take a moment right now to, take a second and see if there are any questions about the general purpose of t-tests or the assumptions that are associated with it. Okay. All right, you guys are doing great. Just want to make sure you know that. All right. So the last slides I'm going to refer to tonight before I begin to discuss the homework. Let me see. Are, if I can get to them, the t-test output. Here we go. Okay, and if somebody can just verbally say that they are able to see the independent t-test output interpretation.
Yes, I can see it.
Great, thank you so much for your response. Okay, as stated, and if you go back to the first slides we looked at as far as t-test goes, when we were actually face-to-face, there are a few different designs of t-tests. We won't visit them all as far as this class goes, but if you come across, varied names for t-tests in your readings, just understand fundamentally what's going on with that particular test, and then you're able to discern why that researcher, chose the variables he or she did, and the dependent outcomes that they did to analyze certain phenomenon. The interpretation we're going to review tonight is for the independent t-test output. So in essence, this is in alignment with the assumptions that we just referred to, and then the slides we talked about as far as the purpose and the intent of t-test. This is what this is associated with. There may be varied outputs for paired samples t-tests, in which you'll have to decipher and pull out information from that type of t-test design. But for the sake of this class, we just focus on the independent t-test output, and this is the extent of the understanding and comprehension of t-tests that we go to in this class. Okay. So the first slide really just is revisiting, going back to the purpose of a t-test. I'm going to go through a few of these just so that we can begin to understand how the variables are broken down. And then the next few slides are going to begin to show you the tables and the outputs, and I'll talk about how you begin to interpret that. My best advice to each of you right now is to take notes. If you are taking handwritten notes, I think that's great. If you're taking notes on the computer, I also think that's great. But you want to make sure that you are going through each of these points and making your side notes, because when you refer back to the homework, the worst thing that could happen is that your memory has totally left you from what we discussed in class today. And so the best way is to go ahead and put it in your own terms, make sure you're making your own connections, drawing your own visual aids if needed. If you needed to draw the bell curve to understand that assumption, make sure that you're taking those steps, because again, once you go back and refer to homework number 3, you want to ensure that you're able to recall this information and apply it to the practice. So the independent samples t-test, or independent t-test for short, compares the means between two unrelated groups on the same continuous dependent variable. So again, that's very important to understand about t-tests, that we're going to have two unrelated groups, group A and B, males or females. Group 1 and 2, intervention A, intervention B. They're going to be two unrelated groups, but they're going to be compared on the same continuous dependent variable. So going back to that example I had earlier, in which we're looking to understand gender differences on STAR test scores. And so we have a group of males, a group of females, and then the means in which I'm going to compare them on are their STAR test scores. It goes on to say, for example, you can use an independent t-test to understand whether first-year graduate salaries differed based on gender, i.e. your dependent variable would be first-year graduate salaries and your independent variable would be gender, which has two groups, male and female. And so while that sentence is very short, I want to break it down because it actually has a lot of information contained therein. Number one, it can be used as a model for your own study. In the exercise, if we were going to be in class, the assignment would have been to create your own t-test study. And for those of us who may not know where to even begin with that, one way or one strategy is to refer back to the slides to see how the questions are posed when researching a phenomenon using this particular model. And so in the second bullet, it states you could use an independent t-test to understand whether first-year graduate salaries differed based on gender. If you were to write your own research question, and again, this really speaks to some of the things we're doing in 905 as well, maybe your question is, how do first-year graduate salaries differ based on gender? That in and of itself is a research question. And how do we analyze that? Well, we can use a t-test to analyze that. And so here your dependent variable would be first-year graduate salaries. And remember, the assumption is that first-year graduate salaries is going to be measured on a continuous scale. Remember, it's going to be some kind of score and some kind of number. When we think about first-year graduate salaries, they may be in certain figures such as, 20,000, 25,000. So when we think about numbers and we think about t-test, remember your dependent measure has to be on a continuous scale. And then for this particular example, your independent variable is gender. Now, gender is not two unrelated groups, right? Your independent variable is gender. However, it does have two independent groups, male and female. So as you look at the homework, and I'll go into it a little bit in the next few moments, but for the t-test, you're going to have one independent variable and you're going to have one dependent variable. Your independent variable can have two unrelated groups. And once it has more than two unrelated groups, then it goes beyond the t-test. And we'll talk about, and that's how the models become a little bit more complex in nature. And so, but for the sake of this particular model, again, you have one independent variable and one dependent variable. Your independent variable is gender, which has two levels, two factors, or two groups. You also may hear it referred to as that, male and female, and then the dependent variable, first-year graduate salaries. So we're going to compare the first-year graduate salaries of males and then to female first-year graduate salaries. And using the t-test, we're going to determine whether or not there is a statistically significant difference between the two groups. It goes on to say, alternately, you can use an independent t-test to understand whether there is a difference in test anxiety based on educational level, i.e. your dependent variable would be test anxiety and your independent variable would be educational level, which has two groups, undergraduates and postgraduates. So as you're making notes to these particular slides, remember you have one independent variable for a t-test and one dependent variable for the t-test. Your independent variable has two groups or two levels or two factors. For the last example on this particular slide, the independent variable is named educational level, and it has two groups, undergraduates and postgraduates. So for the t-test, we're going to be comparing undergraduates versus postgraduates, and we're going to be comparing them on their levels of test anxiety. Now, while the way which test anxiety would be measured is not explicitly stated. Remember, the assumption is that test anxiety is going to be measured on a continuous scale. So that way we can ascertain the scores to create an average that the t-test needs to compare the two groups and then make the comparisons within groups, which produces the t-statistic for us. So this is the beginning of the interpretation of the output. And again, if you have not seen SPSS, it's very akin to working with an Excel workbook. You'll have cells. It looks like a spreadsheet. There's drop-down menus, and in essence, you'll input your data, and then you go through certain steps and procedures to run the statistical model in which you want to analyze your data. And so that's why we don't spend a lot of time on hand calculations, but more so time on the theoretical framework that is surrounding these models for your conceptual understanding. What this next slide states is that SPSS statistics generates two main tables of output for the independent t-test. So if your data passed assumption number 4, there were no significant outliers. And again, this really speaks to making sure that your data is cleaned up, making sure that there are no data points or scores that are found within the, in the far side of the right tail or far side of the left tail, so that it doesn't skew our averages and therefore we get more accurate results. It also, if your data meets the assumption number 5, your dependent variable was approximately normally distributed. So again, this concept of normal distribution for each group of the independent variables. So we want to ensure that those scores for each of the groups that we're comparing fall normally on that bell curve. And then for the last assumption, homogeneity of variance, we're going to visit that as we look at the output. How do you determine if that assumption has been violated? So then the two main tables you will need to interpret for t-test are the following. So this is the first table, and this is called the group statistics table. Okay. And notice I don't have any language written underneath this particular table. You may have a question on that comprehensive examination that just simply has the two outputs of the t-test and asks you to interpret them. And this is the only thing you may see. And so I'm going to walk through how do you interpret this table, and then the second main table, and then how do we write up the results in accordance to APA standards and providing the t-statistic that's reported in the study. So in this particular study, the researcher was interested in looking at two groups. One group was a group that underwent a diet-controlled regimen, and the other group underwent an exercise-controlled regimen. Both groups were overweight men, okay, and they were randomly assigned to either the diet or the exercise group. At the end of the period or the study period, after the diet and exercise intervention have been applied, the researcher then collected the cholesterol concentration for each of the participants and then compared whether the diet group or the exercise group had a decrease in their cholesterol concentration. So whether or not this researcher wanted to determine whether or not diet or exercise had more of an impact on cholesterol concentration. And now, how do you discern that information? So some of it, of course, it's because I've taught this class numerous times and I'm very familiar with the example. But even if you didn't have all that information, and if you were just staring at this group statistics platform, understanding fundamentally what t-test does, you'll start here and look at the group. And here is where we'll understand what groups were under the investigation. And we know that t-test takes into consideration 2 unrelated groups. So here are our groups. We have our diet group and we have our exercise group. How many participants were in the diet group?
$20.
Very good. How many were in the exercise group?
20.
Very good. How many participants did we have in total?
40.
40. Excellent. And as we go across, we begin to see some of the group statistics regarding each of the groups under study. So here, when we look to the left, and I'm sorry to be jumping around, but here, cholesterol concentration, this is our dependent variable. Now remember, for the purposes of t-test, we only have one independent variable and we have one dependent variable. Our independent variable for t-test has 2 groups max, right? And for this particular example, our groups are diet and exercise. If you were to come across a question on the homework that said identify the independent variable and the factors related to the independent variable, the answer would be the independent variable is it would be the intervention style. It could be considered the strategy, whatever broad term you can think of here to encompass diet and exercise. And then the 2 groups would be diet and exercise. Okay, so for the purposes of this example, we're just going to consider the independent variable as the intervention style. And for this particular example, we had 2 types of intervention style, the diet style and then the exercise. And remember, each group was then measured for their cholesterol concentration, and the means and the standard deviations are as follows. So the mean here means what was the average score or what was the average cholesterol concentration for the diet group. And that number is what? What was the average cholesterol concentration for the participants in the diet group?
6.1450.
6.14, very good. So we see here that the cholesterol concentration level for the diet group is 6.115. And for APA, we only usually do 2 decimals and round the second decimal up according to this 3rd place. And so here we see that their average is 6.15 for the diet group. And then what's the cholesterol concentration for the exercise group?
5.79.
Very good. So 5.79 or 5.80 we see for the exercise group. Now, just eyeballing the means of the cholesterol concentration for each of these 2 groups, which group had a higher cholesterol concentration number?
Diet.
The diet group. Very good. And that is as far as we can interpret or infer from the group statistics table. We understand the groups that are under study, the 2 groups according to the t-test. We see what the dependent variable, what that was being measured. We understand the number of participants in each of the groups. And we also have the means for each of the groups and the standard deviation. Now remember, the standard deviation, you can pretty much think of this as the variance between the scores. And so we have the standard deviation for the diet group and the standard deviation for the exercise group. Now and also the standard error of the mean is also reported. But I want you to keep in mind these columns, the mean, the standard deviation, because they'll need to be reported when we report the entire test statistic. So again, for t-test, there's going to be two main outputs once your data pass the assumptions as stated. It's going to produce the first table, which is the group statistics table. And again, this table is going to tell us what the independent variable is, what two groups are included in that independent variable, the dependent variable under measurement, the number of participants, and the means and standard deviations for each of the groups under study. All right, so the next table, and I know you all have seen this table, some of the articles that you've seen, read for class, maybe some of the dissertations that you've gone over. So from this point on, no longer can you just scan over this table, because now you have an understanding of how to interpret it. So aside from the group statistics table, the second output that you'll need to interpret is the independent samples test table. And I'm going to start with the various parts of the table first, and then I'm going to tell you how then we interpret this particular table. So the first part I'm going to tell you about is the different parts of the table. So here we have the Levine's test for equality of variance, and I'm going to go back to this in a few minutes. This really speaks to the test for the assumption of the homogeneity of variance. Again, if you're taking notes, if you have this pulled out, if you are writing on the computer, you want to make sure you identify this part of the table as the part that tests, the test that tests for the equality of variance or the homogeneity of variance. And so we want to keep that in mind as we, because it will lead us to interpret our results when we get to this side. Here is the t-test for equality of means. So in this portion, this is where we're going to draw a lot of our information from as well. Here you'll see the t, this actual statistical notation t, DF, degrees of freedom, right? Significance, two-tailed. So this is going to tell us whether or not our results are significant. It also provides to us the mean difference, the standard error of the difference, and then the upper and lower intervals, confidence intervals. Now, mainly the mean difference, standard error of the difference, and the 95% confidence interval of the difference. These are items that can be reported when you report the t statistic, maybe for the purposes of dissertation or contingent upon the field of study, they may require you to report these things. But for tonight's class, the requirement and for the homework, I'm not looking for the reporting of these particular items, not the mean difference, the standard error of the difference, or the lower and upper intervals. We're mainly going to focus here on the t statistic, the degrees of freedom, and the significance. Okay, so that kind of explains this side of the table. If I go over here, cholesterol concentration, remember we understand this to be our dependent variable. So this is the dependent variable that's under investigation, and it's going to determine whether this table is going to tell us whether or not our groups differed statistically significantly from one another. Now, the next part under cholesterol concentration is equal variances assumed, equal variances not assumed. So remember, if we draw back to our assumption about homogeneity of variance, one thing we want to ensure is that we do have homogeneity of variance. In other words, we want to make sure that the variance found within groups is the same for both groups, so that when we do the comparison, we'll get the most accurate results as possible. And so how do we determine whether or not that assumption is being met or if that assumption is being violated? Well, we simply go here to this Levine's test for equality of variances. we go down to this particular part of the table that is signified with SIG period, which is short for significance. We're going to go over and we're going to look at this significance column, and we're going to see the number that's reported here. And the number that's reported here, somebody say it out loud.
0.579.
Very good. So 0.579. So once we interpret this number, how we determine whether or not the assumption has been violated is whether or not this number is greater or less than our 0.05 alpha criterion. So when we interpret 0.579 or 0.58, is that greater or less than 0.05?
It's greater.
0.579 or 0.58 is greater than 0.05. Therefore, our assumption has not been violated. So the rule is here that whenever you're looking at the independent samples test and determining whether or not the assumption of homogeneity of variance has been violated, you look at the significance column that's associated with the Levine's test for equality of variance, and you look at that number and you determine if it is greater or less than 0.05. If it is greater than 0.05, then the assumption has not been violated. In other words, you do have homogeneity of variance, and equal variances are then assumed. Does everybody see this? Just give me a thumbs up.
Yes, ma'am.
Okay, great. So again, just to kind of reiterate, if this significance column for the Levine's test of equality is greater than 0.05, our alpha criterion, then, then the assumption has not been violated, and we then interpret equal variances have been assumed, and we draw our numbers from this side of the column. If this number happened to be less than 0.05, in other words, 0.04, 0.03, 0.01, anything smaller than 0.05, and it's found to be significant, then we would say our variances, equal variances, are not assumed. And then we would interpret the numbers on this side. So the t-test is robust in that it gives us an opportunity to, one, remedy any of the assumptions that have been violated. And then for the assumption of the homogeneity of variance, you also have an opportunity to draw from a particular set of numbers that either assume that the assumption has been violated or the assumption has not been violated. For this particular output, 0.579 or 0.58 is greater than 0.05. Therefore, it's not significant. Therefore, our Levine's test for equality of variance, our assumption has not been violated. Equal variances are assumed, and we'll draw our t-score from this side of the column. If this number was less than 0.05 and found to be significant, then we would look to this column, equal variances not assumed, and draw our t-score and our other numbers we need to report from this side of the column. Okay, so this is what this means. This really speaks to the homogeneity of variance. And the reason why there's two columns, again, is because the t-test is robust enough to produce results even if the assumption for homogeneity of variance is violated. Okay, so other particular areas of this table that you need to understand now are that now that we've determined that equal variances are assumed, we'll look at these numbers here on this side. So the T-score that's reported is 2.428 or 2.43. Now, remember drawing back to those first few slides, remember that said that the T-score of 3 was considered what? Does anybody remember? If you don't remember, I would really encourage you to go back, but a T-score of 3 is considered large. And so therefore we could kind of start to assume, we're not going to make any hard assumptions yet, but we're going to assume that since this number is close to 2.5 and we know that a T-score of 3 is considered large, that there are going to be some differences between the two groups under study. And remember, the two groups that are under study, I'm sorry, you guys, are the diet and exercise groups. So you got to keep that in mind as we interpret this output. The degrees of freedom are reported as 38. And then the significance is reported as 0.020. Now, how do we determine then if there was a statistically significant difference between the groups? Well, our answer lies right here. And we start by, in our minds or even out loud, by saying, is this number, is this number 0.020, is this greater than or less than 0.05? So I'm asking that in real time. Is 0.02 greater than or less than 0.05?
Less than.
Less than.
It's less than 0.05. Is it less than 0.01?
No.
No, it is not. So this particular answer, 0.020 or 020, is less than 0.05. And remember, our alpha criterion levels generally are 0.05, 0.01, 0.001. These are our cutoffs. And so anything found to be equal or less than would be considered significant. Since 0.020 is less than 0.05, then we can then determine that there is a statistically significant difference between the cholesterol concentrations of the diet and the exercise group. And this is where we actually begin to start drawing our first inferences. And this is why they refer to this part of statistics as inferential statistics. Because again, in descriptive statistics, we understand that we're painting the picture of what's going on with the sample, but when we draw inferences, then we're looking at these statistical numbers and aligning them with our alpha criterion cutoffs to draw inferences on whether or not there was a statistically significant difference between the groups. Based on these results, the answer or the result is that yes, there is a statistically significant difference between the interventions applied on cholesterol concentration between the diet and exercise group. And that's based on this number right here. Okay. Now, on this bottom part, it states that looking at the group statistics table, we can see that those people who undertook the exercise trial had lower cholesterol levels at the end of the program than those who underwent a calorie-controlled diet. So again, just drawing back to this, we see that the exercise group had lower mean averages than the diet group. But the t-test has also determined for us that these two groups are statistically significantly different from one another, and that based on the descriptive statistics, we can now also interpret that those who were involved in the exercise group had statistically significantly lower cholesterol concentration levels than the diet group. So as a researcher who actually conducted this study, I might then be able to take these results and inform practice. I might then incorporate more exercise and maybe less attention on diet, since we find that there are statistically significant differences between cholesterol concentration at an end of a period using exercise as opposed to diet. So there are a number of ways in which you can kind of word it, but again, those are the inferences that we draw from this table based on the T statistic that's provided. So how do we write this up? Well, this is the last slide. And again, this includes some information that I mentioned in the general description of the study, but in overall, in summation, this is how you would report the result. Okay, so again, if you're taking notes, this is important to note because it'll serve as a model on how you write the results up for your homework. So this study found that overweight, physically inactive male participants had statistically significant lower cholesterol concentrations at the end of an exercise training program compared to after a calorie-controlled diet. So in this particular description, what is reported are the means and the standard deviations. So if we go back, and I don't want to toggle back and forth too much, but just so that you get an idea of where these numbers are coming from. Here, 5.80, remember that's the mean that's reported for the exercise group. And then they also report the standard deviation. And then they go on to report the mean for the diet group and also the standard deviation. So here you see those numbers, 5.80, and the inclusion of the standard deviation. This is just how it's being measured as far as that cholesterol concentration. That's what these mean. But generally, you would report the means and the standard deviations for each of the groups. Okay, and for t-test, you're only going to have 2 groups, so you know in your mind that you'll be reporting at least 2 means and 2 standard deviations. And then at the end of it, it also includes the T statistics. So as I referred to earlier, well, how do you report that? Well, T, it starts with this little t in statistical notation, open parentheses, then it includes 38. This 38 number, if we draw back to that table, is the degrees of freedom. So first we write the small t. This indicates that we're reporting the T statistic. Open parentheses, include the degrees of freedom, close the parentheses, then you include the equal sign, and then here, this is where you write out the actual T score. So if we go back to the table, the T score is 2.428. So when they report it, it's here in the statistical notation. And then there's a comma, P equals 0.020, and we know that number comes from the significance column. So basically in this result, it's telling us in written form what the result was of the study, in addition to the inclusion of the means and standard deviation. And then lastly, reporting the T statistic, T, the degrees of freedom, the actual T score, and then the P value, or the significance value, which is reported here, okay? Sometimes you'll see this p-value also reported as less than 0.05. We could actually report that here as that, but in this particular notation, this researcher decided to use the equal sign, which is also acceptable, and then you just write the number that was found in the significance column. So sometimes you may see them interpreted or written out in those 2 ways. All right, that concludes the interpretation portion of understanding t-test. You guys are doing great. I want to go ahead and wrap up, get us off the line by 7. I wanted to spend the last moments reviewing the homework so that you can begin to see the correlation between the homework and what was discussed tonight. And so here is the homework. All right, so homework number 3 directly comes from the t-test interpretation lecture slides we just went over, in addition to the previous 2 slides in the understanding of what's occurring with t-test. So for homework number 3, it asks you to interpret the t-test output below and answer the accompanying questions. Here, as opposed to the sample example I just provided with the lecture I just gave, there's actually a little paragraph that gives you some insight into what the researcher wants to do. And it states, in the example, the researchers are comparing the mean writing scores between the group of female students and the group of male students. Ideally, these subjects are randomly selected from a larger population of subjects. So here we begin with the researcher's goals. The first table you'll need to interpret is the group statistics table, the one it's very similar to what we've just gone over, and answer the accompanying questions. How many participants in the total sample? And as you're reading each one of these questions, make sure that you're reading them and rereading them to really understand what's being asked to report. So question A, how many participants are in the total sample? Question B, what is the independent variable under study? Are there levels, factors associated with the independent variable? If so, what are they? How is the independent variable measured? What is the dependent outcome under study? How is the dependent variable measured? And then it goes on to say, report the means and standard deviation for each level of the independent variable identified. Okay. And then on this last part of the homework, it asks you for G to report the T statistic, and then H, write up the results of the study based on the outcome. So this really refers back to that last slide that we just went over as far as the interpretation. For G, I'm going to be looking for that full written out T statistic results. So with the parentheses, with the equals, that entire statistical notation to report the T statistic. And then as far as write up the results of the study based on the outcome, I want you to tell me in written words, what were the results of the outcome? And again, I would use the slides from the previous lecture about the interpretation as a model so that you're able to write the results of these particular outputs. Okay, so again, this homework is in direct alignment with the course material we just reviewed, and you should use that course material to aid you in completing the homework. The homework will be due next week by the 7th, and then additional homeworks will pretty much follow the same format, be in alignment with course material covered during the lecture. All right, right now I'm gonna go ahead and stop. Talked long enough. I wanted to answer any questions that you may have regarding the homework or the lecture materials that were just reviewed. Okay. Well, if there aren't any questions, feel free to email me if you'd like me to answer something for you in that format. Also, the recording will be available after we conclude tonight's session, so you can go back and revisit portions of this section for more interpretation or further interpretation of some of the concepts discussed tonight. If there are no further questions, you guys have a great night. And my hope is to resume face-to-face next week, but we will see. I'm not sure. You've had formats now in online and face-to-face. I would love to hear from you if you are seeing that now you have a preference, or you're maybe okay with moving to online education. Well, I just want to kind of leave these options open, or if you're noticing that face-to-face engagement is a little bit better for you, I want to assess that as well. So if you have any feelings about it, feel free to email me and I'll take it into consideration as we move forward with the next continuing weeks. All right, you guys have a great night, and I'll talk with you soon.
Thank you, Doc.
Have a good night.
Yeah.
Bye, guys.
Bye-bye.